Hey guys, I thought it'd be useful for me to take a second to actually try one of the homework problems you've been doing. I went ahead and I went to page 49. Problem 1 is one of the acceleration problems. I figured in case there's someone out there that's stumped, you guys like to see me do one. I don't mind doing one. The rest of them you should try on your own, but this first one we'll get. Here we have, like I said, problem 1. So when the shuttle bus comes to a sudden stop to avoid hitting a dog, slows from 9 meters per second to stopping 0 in a second and a half, 1.5 seconds. Find the average acceleration of the bus. Now, to first find this acceleration, we need to know the equation for acceleration. The equation here is the acceleration is equal to the change in velocity in a time period. Or another way you can write this equation is A is the final velocity minus the initial velocity, all in a time period. The second equation here will be useful to us for, well, let's go ahead and start. In any problem, the first thing we always want to do is write down the given information on the problem. Here it starts at 9 meters per second, so we're going to say its initial velocity is 9.00 meters per second. That's the speed it starts at, its initial velocity. The velocity it ends at, its final velocity, is 0.00 meters per second. This is the, like we said, the velocity it ends at. And the amount of time it takes, this right here, this 1.5, the time it takes, it's a duration of 1.50 seconds. Now, it is asking us to find the acceleration, so I'm going to say A equals question mark. Seems silly now, but one time in the future you might be forgetting what you're solving for in a problem. Something as simple as this will help prevent that. So we have our information, we have our equation. All we have to do now is take this information and plug it in. So we have A equals the final velocity. The final velocity is 0.00. Minus, forgot the units, meters per second, minus the initial velocity. The initial velocity is 9.00 meters per second. It's nice, bright background. Alright, anyway, all of this is divided by, the whole thing is divided by the time period, which is 1.50 seconds. Simplify the top, we have negative 9.00 meters per second over 1.5 seconds. Right. A little bit of math. 9 divided by 1.5. Yep, it's 6. But more importantly, it's not just 6, it's negative 6.00 meters per second squared. Now, this here is the acceleration of the object. It's important that we note three things on this. First of all, note the amount of significant figures I used. In the information we were giving, we had 1, 2, 3, 1, 2, 3, 1, 2, 3. We all had a similar amount of significant figures in all these. Actually, the first one, there's an infinite amount, the second one, there's an infinite amount, but we won't worry about that. There's 3 significant figures in all these, so my answer is going to have 3 significant figures. The negative, because of the way the math worked, the change in velocity came out negative. That means that the speed was decreasing. And lastly, the unit I used was meters per second squared. All key points to make sure that we get a good, correct answer. The rest of the problems are done very similar. Write down your given, write down what you're going to solve for, make sure you write down the equation you're going to use, plug the information in, and solve, making sure you put the correct units on there.